This next class, I'm going to show you how we can use the TI to help us come up with a confidence interval for standard deviation. So I'm going to press the Stat button and enter this data set into my editor. So I'm going to hit Top, Clear, Enter, and I'm just going to put in the data real quick. Alright, once I have it in there, I can press Stat and get my 1var stats. So that is Calc 1var stats, and there are the key stats. The big one is S. I need that value for S. Okay, so S is going to be part of the calculation that we do at the end, which is the square root of the degrees of freedom times S squared over these chi-squares R and then L. Alright, R first, then L. Alright, so we need a 90% confidence interval. So what I'm going to do is go to Math Solver. So 90% confidence, if I subtract 1 minus 90.9, I get 0.1, and if I divide that by 2, I get 0.05. So I'm going to start off with that, 0.05. That is the area that's going to be in each tail of this chi-square distribution. Remember, chi-squared is right skewed, so that's 5%, and the low tail, that's 5% of the upper tail. The chi-square distribution always starts at 0, so for my first interval, x is going to be the upper number, 0 is going to be the lower. For my second interval, x is going to be the lower number, but there is no defined upper number in the chi-square distribution. So I would just put a bunch of 9s for that upper number. Alright, so the way this works, I'm going to use the 0.05 and I'm going to subtract, so minus second var's chi-square CDF, not PDF. Lower number is x, lower number is 0, upper number is x. And my degrees of freedom is 1 less than how many values I have here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So degrees of freedom is 11. Alright, here you just guess what this number is. You pick whatever you want. I'm just going to pick 5, just an arbitrary number bigger than 0. You can't pick a negative number. But I'm picking 5 and then just waiting to see. It's going to update it for me anyway. So 0.45, we need this number to 3 decimal places. So 0.4575. Alright, so that was x. So notice if I hit x, it's still stored in there. So I'm going to store that temporarily as alpha A. Alright, so now A, if I press alpha A, that's that button. Okay, now same thing, I'm going to do Math Solver, and I'm going to go back up a screen, and I want the 0.05 in the right tail. So I don't know the number where it's going to start. I just know it's going to go on to infinity. So I'm just going to pick a big number for the right end. Alright, degrees of freedom is the same as it was before, so it's still 11. Close that off. It wants to know a guess. So again, it just has to be something bigger than 4.5, so I'm going to guess like 8. Alright, alpha, enter. Alright, so updated it to 19.675, but again, I can hit second mode. That was x, that's my new value for x. Right, I'm going to store that this time as alpha b. So store alpha. Alright, now notice again, b is larger than a. So when I'm making my confidence interval, I'm going to divide by b first, then divide by a. If you divide by a bigger number, you get a smaller overall fraction. So this will be with the 19 in the denominator, this will be with the 4 in the denominator. Alright, so what I do here, this is where the square root of my degrees of freedom times s squared over these two values. So the first one, again, I'm going to divide by the bigger number first. So I'm going to divide by the b first, and then in the second box, it's going to be the degrees of freedom times the s squared over a. Alright, so here's how I'm going to do it. So clear, it's square root, my degrees of freedom, there's again 12 values total, so my degrees of freedom is 11 times. Now s squared, if I press bars, go down to stats, I did my one variable stats just a little bit ago, sx was calculated, so I can square that. Alright, and then I'm going to divide by, oops, this needs to be under the parentheses too, insert a parentheses, and divide by, and now we're going to divide by b, alpha b. There's my lower number, 3 point, again to 1 decimal place, 3.3. And then my upper number, all I have to do is hit second enter, or bring back the last thing I just did, and I'm just going to change the b to a. and there's my upper number. Notice it is bigger. You can also just divide 1 by B, 1 by A, and just the lower number first, the bigger number second. So this would be 6.9. All right, and there is my confidence interval. So a lot of work getting it from data, but it would beat, in my opinion, it would beat using the critical values in the table if you use that technology. All right, the last question is, does this confidence interval describe the standard deviation for all times during the week? And the answer is no, because it says it was obtained at 3:30 p.m. on a weekday. So no, it's not. It's just where you got your data from. It's not for all data points. If you randomly selected a little bit on a 8 a.m. on a Monday and 2 p.m. on a Wednesday and 6 p.m. on a Saturday, you randomly selected different times, then you can say it's for all times. But with it being that specific, 3:30 p.m. on a weekday, you can't say it's for all times.